So October 19th, 2025, Amazon Web Service, or AWS, the backbone of nearly half the internet, went dark. Not from a cyber attack, not from a natural disaster, but from a race condition in their DNS system. One simple bug. Banks, government, services, streaming platforms, all knocked offline because Amazon's unbreakable infrastructure went down. Went to its knees, and an unbreakable infrastructure had a weakness that nobody saw coming. So after watching cloud providers promise 99.99% uptime for years, this outage exposed something terrifying. Even the most sophisticated systems can collapse from the simplest mistakes. So I'm going to break down exactly what happened, why it matters to your business, and some brutal lessons that every tech leader needs to learn from this disaster. Let's dive into this today. So the AWS outage wasn't just another service disruption. It was a wake-up call. When the company that powers Netflix, Reddit, Slack, and thousands of government systems goes down, we need to pay attention. So this wasn't a sophisticated attack or a hardware failure. It was something far scarier, a preventable software bug in a system designed specifically to prevent these kind of failures. So we're going to dive into what really happened and what it means for anyone running systems in the cloud. Now, hey, before we go any deeper, make sure you leave a comment down below because seriously, it's my favorite thing and the best compliment that you can give me. And so I read every single one and they help me to shape my future videos. So make sure you leave a comment. Now let's dive into some of these articles. All right, so a single DNS race condition brought Amazon cloud empire to its knees. Fault in DynamoDB system cascaded through AWS service, knocking major sites offline for hours. So Amazon has published a detailed postmortem explaining how a critical fault in DynamoDB's DNS management system cascaded into a day-long outage that disrupted major websites and services across multiple brands, with damage estimates potentially reaching hundreds of billions of dollars. Man, hate to be that guy who deployed that bad patch. Amazon postmortem says the error rate was triggered by a latent defect within the service's automated DNS management system. The race condition occurred when one DNS enactor experienced unusually high delays while the DNS planner continued generating new plans. A second DNS enactor began applying the newer plans and executed a cleanup process just as the first enactor had completed, so essentially causing the cyclical race condition, they call it. And so, according to Akamai, it says a major outage in AWS took down the digital service of many main brands. Engineering teams worldwide found themselves in an impossible position. Their monitoring dashboard showed failing services and customer support channels flooded with complaints. The failure exposed a critical architectural vulnerability. When a cloud provider's fundamental services fail, even well-designed multiple availability zones offer no protection. So they go through everything, and so everybody's going through and really looking at these postmortems to see what it is that we could learn as engineers. And I want to kind of talk a little bit about what are some lessons that we can learn from this as engineers. So now, so let's go through it a little bit slower here. Amazon's US East region powers a massive chunk of the internet, and when it failed, the cascading impact was immediate and brutal. The outage started with DynamoDB, Amazon's managed NoSQL database service that millions of applications depend on for critical data. What makes this terrifying is that companies specifically chose AWS because they're told there's no single points of failure. So in architecting systems for a lot of years, the sales pitch is always about redundancy, failover, and resilience. The irony here is thick. A system designed with multiple independent components failed because those components weren't actually independent. This exposed the fundamental flaw in trusting any single cloud provider architecture claims without verifying them first. Now, the root cause was embarrassingly simple: a race condition in AWS's automated DNS management system. For those who are unfamiliar, a race condition happens when two processes compete to update the same resource and the timing determines the outcome. In this case, unusually high delays in one DNS component caused another component to think all the IP addresses had disappeared. The automated system then did exactly what it was programmed to do. It deleted what it thought were stale DNS records. Except those records weren't stale, they were actually active IP addresses for critical AWS services across the region. So after a long time in software, I can tell you that race conditions are notoriously difficult to catch in testing because they only appear under specific timing conditions. Now, once the DNS records were wiped, AWS services couldn't find each other. So the problem is they couldn't even log in the systems to get them to talk to each other. So imagine trying to make a phone call when the phone book when all your contacts disappear. That's essentially what happened here, right? DynamoDB's regional endpoints became unreachable first, triggering API errors across thousands of applications. Services that depend on looking up other services via DNS started failing in cascading waves. EC2 instances couldn't launch because the control plane couldn't resolve the addresses it needed to provision new servers. So networking components that relied on DNS for service discovery started routing traffic to nowhere. The failure spread throughout AWS's infrastructure like a virus, each failing service taking down the service that depended on it. So EC2, Lambda, ECS, EKS, Fargate, basically every major compute service started experiencing failures because all of their DNS records were zeroed. Companies running containerized applications watched their entire infrastructure become unresponsive. Serverless functions that normally scale automatically were just gone, unable to process requests. The cascade happened faster than AWS engineers could react because automated systems kept trying to fix the problem by making them worse. So I built distributed systems, and this is a nightmare scenario when your automated recovery systems become part of the problem. The cascading failure lasted several hours, because fixing DNS issues requires careful manual intervention, and you just can't restart everything, right? There's no one computer to restart. Now, AWS constantly markets itself as the gold standard for high availability with redundant systems and automatic failover, but this outage revealed that high availability is only as good as the assumptions built into the system. The DNS management system was supposed to be resilient with independent components that could function even if others failed. Instead, a latent defect, a bug that had been hiding in the code, waiting for the right conditions, brought everything down. Companies paying premium prices for AWS's enterprise-grade reliability watch their businesses come grinding to a halt. After a long time building software, I've learned that every highly available system has hidden dependencies. The question is whether you discover them during testing or during an outage. Now, if your company has systems and you need help getting them built, check out startuphack.com/Spencer because we'd love to help your company get your systems connected to work to maximum efficiency. Check out startuphack.com/Spencer. Now, websites went offline, e-commerce transactions failed, SaaS platforms became inaccessible. The financial impact was huge. Every minute dev downtime cost businesses real money, lost sales, SLA penalties, emergency response codes, etc. Some estimates suggest AWS outage cost the broader economy hundreds of millions of dollars per hour. So companies that had architected everything around AWS suddenly faced questions from executives. Why do we put all our eggs in one basket? Now, the reputational damage extends beyond just AWS. It shakes confidence in cloud computing as a whole. So I've advised companies through outages, and the real cost isn't just the immediate downtime. It's the months of incident reviews, architecture changes, and executive scrutiny that follows. Now, multiple government services that had migrated to AWS were knocked offline during the outage. Citizens couldn't access critical services, highlighting the risk of government dependency on commercial cloud providers. This raises serious questions about digital sovereignty, whether government should be outsourcing critical infrastructure. When a private company's bug can prevent citizens from accessing government services, could be a serious structural problem here. So I've worked with government agencies on cloud migrations, and this outage validates every security and availability concern that they've raised. The political fallout from this is still playing out as legislators question the wisdom of concentrating so much government infrastructure with just one vendor. Now, AWS's official postmortem was revealing in what it admitted. They had a latency defect in a critical system. The company acknowledged that the very system designed to maintain high availability became the source of the failure. So their admission that they needed to look for additional ways to avoid impact from a similar event is a corporate speak for we didn't think this could happen. Now, the postmortem confirmed that despite extensive testing, this race condition had never been caught before. What's scary is wondering how many other latency defects are lurking in AWS's infrastructure, waiting for the right conditions to trigger. Now, transparency is good, but this postmortem essentially confirms that even AWS doesn't fully know all the ways that their complex system can't fail. So how does a bug this critical survive in production at a company known for engineering excellence? The reality is that testing distributed systems for every possible race condition and timing scenario is nearly impossible. AWS runs millions of servers and processes billions of requests. Creating test environments that replicate production conditions is extremely difficult. I've built testing frameworks for complex systems, but you can never possibly test every single possible interaction under every possible load condition. So again, even if you tested this at thousands, it might not have happened, right? This outage proves that even the best engineers and testing practices, complex systems have failure modes that only reveal themselves in production. The lesson here is that assuming any system is bulletproof, no matter who built it, is a dangerous mistake. Now, before this outage, many companies dismissed multi-cloud strategies as too complex and expensive. After watching their entire infrastructure disappear for hours, those cost calculations were being revisited rapidly. Multi-cloud doesn't mean running the same workload on multiple providers, but it does mean having critical failover capabilities. So I've helped companies architect multi-cloud strategies, and yes, it's more complex, but so is explaining to customers where your service is down. The challenge is that building truly cloud-agnostic applications requires abstraction layers that add cost and complexity. Companies are now weighing the cost of multi-cloud architecture against the cost of betting their entire business on just one provider. Now, AWS's infrastructure is heavily automated to handle massive scale and provide self-healing capabilities, but automation is only as good as the logic that drives it, and in this case, the automation made the problem catastrophically worse. The DNS system automatically deleted IP addresses when it detected what it thought was a problem. No human was in the loop to question whether deleting all DNS records for critical services was actually the right call. So I've implemented automation systems for a long time, and the hardest part is building in appropriate safety checks and human oversight, especially when you're moving fast to hit deadlines. So this outage is a reminder that automated systems need circuit breakers, confirmation steps, and ways to detect when they're making things worse, not better. Now, every AWS customer now has to answer a tough question. Can we trust a provider that went down from a preventable bug? The incident report shows that AWS didn't have adequate safeguards to prevent a single component failure from cascading. Companies are reevaluating their cloud strategies, their SLAs, their backup plans, and their risk profiles. The trust tax is the additional time, money, and engineering effort companies now need to invest to protect themselves from provider failure. So I've watched this pattern play out with a lot of major technology platforms. Initial trust, eventual failure, permanent skepticism. So the real cost of this outage isn't just the hours of downtime. It's the years of additional architectural complexity every AWS customer now needs to build. Now, curious to hear what your guys' thoughts are. Do you agree? Do you disagree? I'd love to have a great discussion. So make sure you leave a comment down below and make sure to like and subscribe. Here at Startup Hack, we love to train software developers as well as build custom software solutions for companies. So reach out if we can help your company. Check out startuphack.com/Spencer, and here's some great information about our services.
Hi, I'm Spencer, a fractional CTO. With over a decade of executive leadership and 25 years in software development, I've transformed technology teams and products for businesses just like yours. As your fractional CTO, you get the strategic guidance of a seasoned technology executive without the full-time commitment, perfect for companies ready to leverage cutting-edge technology without expanding headcount. My team at Startup Hack has already built advanced AI agents for small and medium businesses, automating complex workflows and delivering advanced ROI to human workflows. We specialize in creating custom software that connects your systems into a single coherent technology ecosystem. Our development approach focuses on tangible business outcomes. For one client, we developed AI-powered workflows that cut days off of human processes. For another company, by connecting multiple systems, we reduced processing time to increase their ROI by over 75%. We don't just write code, we architect solutions that scale. Whether you need cloud system architecture, data integration between legacy systems, or custom AI agents that automate your unique business processes, my team delivers results that exceed your expectations. Having led technology for a lot of companies and launched 7 successful brands of my own, I bring battle-tested expertise to your business challenges. Our specialty is turning technological complexity into business advantage. So if you're ready to harness the power of AI and custom software to drive your business forward, let's connect. Together, we'll build technology that doesn't just solve today's problems, it positions you for tomorrow's opportunities. Technology leadership, decades of experience, AI powered. Reach out today and we can help you. Check out startuphack.com/Spencer.